Good afternoon, everyone. My name is Nikhil, and I'm an undergraduate student, so please be kind to me with the questions. And I worked on an IoT-powered portable aquaponics system as part of my summer internship in the Indian Institute of Technology and Management, Kerala. So what this essentially is, it's like a small farming system that you can put on your table in your house, through which you can grow some organic food. And you can remotely control it with the use of IoT, which I'll explain more. So first of all, what is aquaponics? Aquaponics is growing fish and plants at the same time, using fish waste as the nutrients for the plant. You can grow lettuce, you can grow tomatoes, on a big scale you can grow even bananas. It's really amazing. And so first you have the fish. The fish excretes some waste. And this set of bacteria known as nitrifying bacteria, they will convert the waste to a form that plants can use. And then the plants take up those nutrients, clean the fish water, and give the filtered clean water back to the fish. So it's like one cycle that is self-sustaining, one setup. And you can grow both fish and plants at the same time using this. So what are the benefits? You don't need soil. You can grow 6 times more food per square foot area compared to soil-based farming. That was not my research, it was someone else. And organic, because the moment you add pesticides to such a system, the whole natural cycle breaks down and it stops working. So this won't work with pesticides or any other chemicals introduced. So it's completely organic, and you save a lot of water. So this is the system that I prototyped during the internship. So what I did was, you know those 20-liter water cans? So you cut them into half, use the bottom bit as an aquarium for the fish, and the top half as the grow bed for the plants. And then you use some aquarium pumps to pump the fish water up to the plants, and then the plants will filter the water and return it back. So this is my system. Yeah, it's all over the place. And so I also added some electronics to it to remotely control the watering and lighting cycle, and added some temperature sensor to measure the temperature of the fish water, because different fish thrive at different temperatures. So it's a useful parameter to measure. And also a water overflow detection system to automatically shut down the system if there's a water overflow event. And all this data and sensor data and control signals are sent through cloud services like Cloudinary, PubNub, IoT Freeboard.io, Duet.io, all IoT services, which I have no clue what's going on underneath. I'm not an expert on IoT, but I use them for my application. And this is the dashboard that I made in Freeboard.io. And as you can see, there's a control button for turning the lights on and off. Take a picture of my system, and because there's a camera as well. So if right now my system's in India, in the lab, and right now if I take up my phone, open up that website, I can light my plants, turn on the lighting for my plants, control the watering for my plants, take a picture to see how it's doing, and also see the temperature. And this is the beauty of IoT, and I find it amazing. And so that's my project, if you want, in a nutshell. So why IoT for this? The main idea is for people who are busy and who don't have the time to grow some organic food in their own home. Such a system is very useful for them. They can just it's just DIY stuff. You just use a 20-liter water can, some simple electronics to it, use existing IoT services, and put it in your house and go wherever you want and start farming. And you can grow your own organic food from anywhere in the world with internet connectivity. Also, with data you measure like temperature or the chemical parameters of the. I'll explain that later, but you can measure the data, sensor data, and pool knowledge on best aquaponic practices. So people can learn, like, if I want to do this in India, what's the best temperature to grow this fish in? It might be different in England or in Spain, so people can pool knowledge very quickly and efficiently. So future work. So right now the system, like I said, it's quite a small prototype on which you can probably grow some spinach and some ornamental fish. And you can scale this up to an aquarium-sized system. So that my colleague in the lab is doing that, Nathan Krishnan. He's working on that now, And also we've noticed that, so I've used, I didn't know this, I've used LED lights assuming that would work for the plants, but I later found out that they don't provide all the wavelengths necessary for the plants to grow. So then there's things called grow lights, which are specifically designed for plants and aquaponic systems. So next time I should use that, grow lights. And this is I would say the biggest advantage, the biggest application of IoT, cycling. So what cycling is to sum it up, it's you're introducing an initial culture of bacteria which will break down the fish waste to the form that plants can use. It doesn't exist there. You have to introduce it somehow. So that's what cycling is. And for me, it took 14 days with manual chemical stress test strips, testing, and taking corrective measures. But say if you have digital chemical sensors and upload that data to IoT, people can learn quicker on how to cycle best. And I would say that's where IoT can be leveraged best. So yeah, that's my presentation. I would suggest everyone, if you have an aquarium, just do some simple, or you can call me and pay me, I can do it for you.
Okay, thank you very much.
Yeah.